So today's lesson is all about neutralization reactions, and neutralization is just a fancy term for when we take an acid and we add enough base to it that the pH goes to a pH of 7. So it's neither acidic nor basic any longer. When acids and bases react, they actually form something called a salt. And if you remember, salts can be any type of ionic compound. They don't specifically have to be sodium chloride, but they will result in a salt and water. And of course, water has a pH of 7 as well. So a typical type of reaction, or one of our most basic ones, we have hydrochloric acid and sodium hydroxide. So a very strong acid and a very strong base. Now, some of you may look at this and say, oh, I know what type of reaction this is. This is actually a double replacement reaction. So what's going to happen, just like every typical double replacement reaction, we will get the outside two joining up and then the inside two joining up. So now in this reaction, we do see that we'll make sodium chloride and water. But that's only with these two will we actually get sodium chloride and water. So because the above reaction is in a 1-to-1 mole ratio of acid and base, it will take an equal number of moles of both HCl to neutralize sodium hydroxide. That's not always the case though, because as we learned in earlier talks about this, sometimes there are acids that are diprotic and triprotic, which means that they have more than one hydrogen in them, as in the case of sulfuric acid. So the same type of neutralization is going to happen here. So we're still going to get the outside two, and the inside two, which are making our products. So in this case, we're going to get sodium sulfate as our salt and H2O. But this won't happen in simply a 1-to-1 to 1-to-1 ratio. Instead, what we're going to see is we would have to add a coefficient of 2 to get this equation to balance out. Don't worry about that. It'll come into play a little bit later, but the balancing of these reactions should be pretty straightforward for the most part. So, how do we use neutralization reactions to talk about acid-base chemistry? Well, for example, in number 10, how many moles of sulfuric acid are required to neutralize half a mole of sodium hydroxide? So this is the equation that actually goes with this, and we're going to have to use a little bit of stoichiometry to figure this out. But really, this is quite simple compared to what we've been doing before with stoichiometry. So, just like we've started off in the past, we're going to write down what we're looking for, number of moles of H2SO4 are required to neutralize 0.50 moles of NaOH. So, to convert moles of sodium hydroxide into moles of sulfuric acid, the only conversion factor we need is the mole ratio. Well, let's look at this in order. Oh, I forgot to balance this whole thing out. So not only do we need two H2O's over here, we need a 2 in front of our sodium hydroxide. So when we use our mole ratio here, we would write down 2 moles of NaOH and 1 mole of H2SO4. And we should get as our answer 0.25 moles of sodium hydroxide. And this should make sense because for every one every one sulfuric acid, it's donating 2 hydrogen ions. So that means 2 of these will have to neutralize out 2 of these OHs. So it's going to take half as much as this to neutralize an equal number of moles. Okay, So example 11, we would definitely have to start off with a balanced chemical equation. But that's okay, not a big deal, one extra step, and we're used to doing this. So potassium hydroxide is KOH, and it is going to be reacting with phosphoric acid, which is actually H3PO4. And again, it's still going to be a double replacement reaction. So we'll get H2O and K3PO4. So when we balance this equation, we should get 3 and 3 over here as well. Okay, so now when we write out our, when we start off our stoichiometry here, number of moles of potassium hydroxide, 1.56 moles of H3PO4, and we know that this is in a 1 to 3 mole ratio, so 1 mole of H3PO4 and 3 moles of, KOH. So 3 times 1.56, and we should get 4.68 moles of potassium hydroxide. So you may want to stop the video at this point and try example 12, and I'll go ahead and show you what the answer should be. Okay, so in our next video lesson, I will actually introduce the idea of titration. And if we were in school, we would be doing probably about a week-long titration lab. Unfortunately, since we are on quarantine, we won't be able to do that, but I will be able to talk about it. So thanks for joining me.